Potentially. You could. You definitely could. But that could get ugly. Right? That could get ugly quickly. And up until now, that's what we've done. If we had, well, I didn't even put one. Like if we had something like this, prior to this point, we would just FOIL that out because and then we would have one single long polynomial, and then we would follow the power rule. And you can still do that, but that can get ugly, and even that can start to make careless mistakes. So if you're taking the derivative of two functions that are being multiplied together, here it is notationally. You take the first function as is and multiply it by the derivative of the second, plus you take the second function, g of x as is, and multiply it by the derivative of the first function. So you'll hear this little quotation come out of my mouth very often, too many times. I just say the first times the derivative of the second plus the second times the derivative of the first. And that ring should, sit with you, and you should be able to apply that. And then the quotient rule is the denominator function multiplied by the derivative of the numerator function minus the numerator function times the derivative of the denominator function all over the denominator function squared. That'll give you the derivative for a quotient type function. So that, just the quicker version of that, bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. That's what I say to myself. I mean, that's just me. That's what I'll say a lot. There's nothing formal about that. The formal rules are in the notation. So here we go. For this g of s, this is the product, so we would do g prime of s equals the first root s times the derivative of the second, which is what? Negative 2s. Plus the second times the derivative of the first. Now that might be tricky. You may want to rewrite that as s to the 1/2 power. So the derivative of that would be 1/2 s to the negative 1/2. So this would be negative 2s root s. That's your first term. And then your second term, this is going to move to the denominator with the 2. And then the 4 minus s squared is still on the numerator. So plus 4 minus s squared is on your numerator over 2 root s on your denominator. And then we can find the derivative at any s value. Okie doke. The second one, still a product rule, but with a trig mixed in there. You may again want to rewrite the original as x to the 1/2 power times sine x. So like here, Josh, you can't avoid it. You couldn't multiply it out. You have to do the product rule. So f prime of x would be your first times the derivative of your second. What's the derivative of sine? Cosine. Plus your second times the derivative of your first, 1/2 x to the negative 1/2 again. And then we would clean this up into root x cosine x. Plus, and again on the second fraction or second product, this is going to move to the denominator with the 2, and then you're just going to have a sine x on your numerator, so 2 root x. Any questions? When you're checking your answers in the back of the book, if they're not in this same format, let's say theirs is written as a single fraction, well then you might have to go further and manipulate, get a common denominator, and so on. Basic algebra skills to make sure that you could achieve that. that answer. Again, if it's open response, there's going to be a lot more options as to what could be written as your final answer, how far you want to take it. There's no just like standard rule. That being said, though, there's not going to be a lot of open response. It's going to be multiple choice per usual, and then you just kind of have to search for the answer. That's going to be an equivalent. Okie doke. So for our quotient rule, again, you can't avoid it here. You would do, I don't think I need to rewrite anything here, so we're going to do our bottom times the derivative of the top, which is just 2t, minus the top, times the derivative of the bottom, which is just 2, all over your denominator squared. So mainly here, the numerator needs to be cleaned up a bit. So if I distribute that 2t, I'm going to get 4t squared minus 14t. Distribute the negative 2, technically, on the second part of the binomial up top, minus 2t squared minus 4, all over 2t minus 7 squared. I'm going to leave that alone. And then just cleaning up the polynomial in the numerator. 4t squared minus 2t squared gives me 2t squared minus 14t minus 4, all over 2t minus 7 squared. If we can factor the numerator and some more things would cancel, you want to try to do that. So definitely in our numerator we can take out a 2. But beyond that, there is no additional factoring of that trinomial. So this would be our final answer for our derivative. Any questions? The next one, quotient rule, same thing. F prime of t equals your bottom times your derivative of your top, which is what? Derivative of cosine? Negative sine. The use of parentheses is important there because if I don't have them, and as you see, I've been using them to kind of show you each piece, the bottom, that times the derivative of the top, and so on. But if you don't use them in a case like this, that could very easily turn into 2t cubed minus sine t, which would be wrong. Bottom times derivative of the top minus the top times the derivative of the bottom, 3t squared, all over bottom squared, which would just be t to the 6 if you want to just jump there. So cleaned up, that would be negative t cubed sine t minus 3t squared cosine t, all over t to the 6th. And in that numerator, I do have a GCF that I can pull out. What is it? Negative t squared would probably be best, right? Because it leads with a negative. So if I pull out a negative t squared, I'm left with t sine t plus 3 cosine t, all over t to the 6th. And then this t squared and 2 of these 6 would cancel, making it only t to the 4th. Questions? All right. So on the back, just no different applications than we've been doing, just one's using the quotient and product rules. So this wants the derivative specifically at c. It wants you to find the derivative equation, but then also evaluate it at c. So f prime of x, why don't you go ahead on your own and find that. Jack, what did you get for your derivative here? Okay, I'm still working on it. How about now, Jack? Did you get there? Cosine squared x. So the x is squared or the cosine is squared? And then what? Anybody have anything different? Winter? So you didn't have the squared part. Okay, so let's look at this. F prime of x, the bottom, times the derivative of the top. The derivative of the top, sine x is cosine x. Minus the top times the derivative of the bottom, which is just 1. Yes? If you want to write that, you can. All over bottom squared. So that would turn into x cosine x minus sine x all over x squared. So I don't think either of you are right. This x with this x? No. Because that's a piece of a polynomial. If they both had an x, and you could technically factor it out, and then it would be a factor of the numerator, then yes. But right now it's a piece of a polynomial. So, okay, and so Jack, what you did, it looks like, is you multiplied this x times this x. But these are the two separate things. You only want to take the cosine of x, and then that answer would be multiplied by x, not taking the cosine of x squared. Do you follow? Okay, so there's our derivative, and then we're going to evaluate it at c of pi over 6. So f prime of pi over 6 is going to be pi over 6 times the cosine of pi over 6 minus the sine of pi over 6 all over pi over 6 squared, which the best we're not going to get a number, but cosine of pi over 6 is radical 3 over 2. So that would be radical 3 pi over 12 once I multiply it by pi over 6 minus a half over pi squared over 36. What can we multiply by on the numerator and the denominator to clear our fractions? Okay, but look at your three denominators. 2, 12, and 36. 36. So if you do that, and I'm going to work to the left so I don't run into my other one. The 36 over 12 reduces to 3 root 3 pi. The 36 and the 2 reduces to just minus 18 all over pi squared. Now, just for the sake of putting some ideas together, at what x value would this not be differentiable? Just 0, right? Because if you do f prime of 0, you're going to get an undefined. Everyone clear with that? Why do we get a slope on this function that doesn't exist at 0? Do you remember what this graph looks like? Sine of x over x. Right? Just like that. So this was that one where the limit rule we had to remember, the limit of this function as x approaches 0 was 1. And so obviously you can see why it wouldn't be differentiable there because there's a hole there. Good? How many people recognize that when they look at the function? Anybody else? I don't blame you for not recognizing it. You get your head kind of buried in this like process of the quotient rule, and you might not realize certain things because you're so focused on the algebra skills. That's normal, but just if you can think about functions, if they look familiar right off the bat, you might make sense of them. All right, the second one here would require the product rule, so take a look at that. Go ahead and try that one on your own. Our answers are up there. Are there any questions? Okay, if I zoom 6, there's the graph of the original function. And it stands to reason maybe why at 1 we have a slope of 0. Yes? I think because at the end of the day, that's a triple root, right? It looks like that. Remember those wiggles? If we actually rewrite this original, isn't it x minus 1 squared? That's what that factors into. This one factors into x minus 1 and then x squared plus x plus 1. So altogether we have x minus 1 cubed and then x squared plus x plus 1. So just a rearranged version of it tells you have a triple root at 1. So it stands to reason why the slope is 0 at 1. Okay, are there any values for k such that f prime of k would be undefined? Any places where the slope is undefined, just look at your slope formula. Is there any place where that would not exist? Of course not. We have a slope everywhere. So your explanation would be because the derivative function is defined for all real values of x. Okay? No. Because f prime of x is defined for all x's that are real numbers. Like that. Okay, and then you're going to come to a section on your homework where it wants you to find the derivative without using the quotient rule. So on this particular function, finding a way to rewrite it, and that would be 4/5 x to the negative second power. So the quotient rule is great, but also try to start to look for what's most efficient, because the quotient rule here probably wouldn't be the most efficient. You could just rewrite it as a typical power rule, differentiate it, so negative 8/5 x to the negative third, and then clean it up, and it would be negative 8 over 5 x cubed. And just really, I just want to show you that and how both methods would work. So if I were to do the quotient rule, I'd have the bottom times the derivative of the top. What's the derivative of the top? 0. Minus the top times the derivative of the bottom, 10x. All over bottom squared would be 25x to the 4th. So this 0 part would be gone, and it would just be negative 40x over 25x squared. And if you reduce each of these by 5, you're going to get negative 8 over 5. This x will cancel with one of these x's. Oh, it was a 4. Sorry. This x will cancel with one of those, so it'll just leave x to the third, and you obviously see that it works either way. So just really shedding some light on the fact that you can do these in multiple ways. Try to get in the habit of looking for the most efficient. Okay? All right, so I have your quizzes to give back. Homework's right there at the bottom.